right, so it's time for the question and answer session of this presentation. I'm looking at the 8 questions that were submitted. I think some of them I already answered during the main presentation, but okay, I'll answer them again. The first question is from Jimmy, and his question was, how safe are these vaccines, and when are you going back to the office? Our accumulated knowledge comes from our experience during the last 6 months, with 70,000 clinical trial volunteers and over 4 million people who already received the vaccine. No one died from either Moderna or Pfizer vaccine. The most serious side effect reported is anaphylactic reaction, which only happened in 2, 3, or 4 cases that I know. 2 of the patients carried EpiPen themselves because they have a history of severe allergic reaction. Even if there are still some unknown and very rare side effect, like 1 in a million, that is nothing compared to your likelihood of suffering the most serious and irreversible side effect of not getting the vaccine. You know what that is? Yeah, death. And it has happened 350,000 times since January 4. So the answer is yes, the vaccine is safe. Now the other question, when am I coming back to the office? Okay. One of the things I've learned during this pandemic is how to conduct a high quality telehealth visit and elevate it to the highest level possible, which included creating a new website optimized for smartphone and for telehealth. I'm going back to the office in April, and then we can all celebrate that we all help each other survive this calamity. The country is deeply wounded. As survivors, it is up to us to help rebuild our economy. I'm going back to the office and focus on what I was doing before, which is saving more hearts and reinvigorating my Save Your Heart campaign. This is my first video on the COVID vaccine. I'll tell you why I decided to take the messenger RNA vaccine, and I'll answer your questions about it. This is Dr. Digoma. This is the good news that many are waiting for. The vaccine rollout has begun. I just got my corona vaccine on December 26 at 2 p.m., a Christmas gift from science and from the hundreds of scientists working to develop this messenger vaccine technology platform for over 10 years. According to experts, about 70% of Americans need to acquire immunity to end this pandemic in the US, either by surviving a natural infection, like what's happening now, but the virus has a long way to go to infect 70% of 300 million Americans. This will take a few years and millions will die. But there is another option. By acquiring immunity through mass vaccination, which has never happened before during a global pandemic because it was previously impossible. The COVID vaccine has the potential to end this pandemic in 6 to 12 months, preventing millions of deaths worldwide and economic devastation and collapse. If it succeeds, it could be the most impactful human achievement so far in this 21st century. So finally, after getting the vaccine, I am more certain of surviving this pandemic. I'm also more certain that there is a future I can plan for. I'm due for my second dose in about 4 weeks. So I got my vaccine. I hope you're getting yours soon also. I know you have questions. So let's have a Zoom meeting and let's talk. Since March, because of the pandemic, I switched from in-person office visits to video medical visits using telehealth. After the Pfizer and Moderna messenger RNA vaccines were approved, the COVID vaccine has become an important topic of discussion during my telehealth visits. Like you, I have many questions myself, but once more data were made public, Those questions were all answered to my satisfaction. Before I answer your questions submitted in advance, let me give you a quick overview of the flu vaccine, which we are all familiar with, and the unfamiliar messenger RNA vaccine. Full disclosure, I'm not a virologist. I am a concerned medical doctor, board certified in internal medicine, cardiovascular disease, and clinical lipidology. So I have quite a bit of medical background. Before I got the vaccine myself, I needed to have a really good understanding of what I'm getting to satisfy my own curiosity, but also I need to have answers to my patients' questions. Let us compare the familiar flu vaccine and the unfamiliar messenger RNA vaccine. The key manufacturing ingredients in making the flu vaccines are chicken eggs and live flu virus. If we were to make COVID vaccine using chicken eggs and live COVID virus, that will take a very long time, maybe 10 years. And who knows what can happen in 10 years. It will take many years and many millions will die. Fortunately, there is now another way, the messenger RNA vaccine. There's actually a third one just approved in UK, the adenovirus vector DNA vaccine. I will not talk about that since it's not yet approved here in the US. The flu vaccine manufacturing requires live flu virus and millions of fertilized chicken eggs. These eggs are inoculated with live virus and incubated under controlled condition. The virus replicates rapidly. After a given period of time, the flu virus is harvested and deactivated. The flu virus is made up of many proteins. So when the flu vaccine is injected into your muscle, you're receiving many proteins from the killed flu virus. For the COVID vaccine, there's none of that. No chicken eggs, no deactivated COVID virus, no viral protein. The COVID virus has 29 proteins identified. The scientists selected one protein, the spike protein, as probably the best candidate for generating strong immune response and best protection. The COVID virus uses these spikes to attach itself to the cells lining our respiratory tract. This is what a spike protein looks like. You're not getting an injection of spike protein. Instead, you will make the spike protein yourself. So, in essence, your own body is making your own vaccine. How is that possible? This is the genetic code of the spike protein. The genetic code of the spike protein is inserted into the messenger RNA made in the lab. This is the messenger RNA. The messenger RNA carrying the code of how to make the spike protein is encapsulated within lipid nanoparticles to keep it stable and deliverable into the muscle cells. This is a capsule of lipid nanoparticles with the messenger RNA in it carrying the code for making the spike proteins, and it's protected inside. Once inside the muscle cells, the encoded messenger RNA is released and the genetic code is read by the ribosomes. The ribosomes starts making COVID-19 spike proteins, which are then secreted outside the cells where the immune system can see them. A complex immune response is orchestrated so that next time the COVID virus tries to infect you, your immune system is already programmed to respond to kill the virus. To save time, but without cutting corners, some things were done concurrently. While large clinical trials were in progress, they developed the manufacturing process to mass produce the vaccine. For the phase 3, there were over 70,000 volunteers in a double blind, placebo controlled clinical trials with good representation of different population groups. After a few months, there were sufficient data to analyze, and the result far exceeded the minimum threshold required for approval, which is over 50%. To everyone's surprise, it was over 90% effective. And the side effects encountered were similar to the flu vaccine. I got my Moderna vaccine last week. It was uneventful, minor localized discomfort the following day that lasted for 48 hours. And that was it. Uneventful, no fever, no body ache, no malaise. My second dose is due in 4 weeks. If this pandemic were to happen, 2020 was the right time. If it happened 5 years ago, we won't have the technology to rapidly develop the vaccine. It may take years. No one knows. It happened in 2020, and we are ready. There are some concerns about the new variant found in UK. It is more contagious, more infectious. More infections mean more hospitalizations. More hospitalizations mean more deaths. The UK variant is already spreading here and will likely become the dominant variant. Get your vaccine as soon as they become available locally. It does not matter which one. This is from Rich. What side effects did you experience? Really, as I said before, a quick prick like you would for a flu vaccine, and then 24 hours later it was sore to touch. Okay, and that lasted for maybe 48 hours, but there was no redness. I didn't have any fever. No achiness, no flu-like symptoms. Really nothing. It was uneventful. Okay, this one is from Mary. Can you get COVID-19 infection from getting the vaccine? No, you can't. There's just no way that could happen from the vaccine itself. I think some patients told me that they got the flu after getting the flu vaccine. Remember, with the COVID-19 vaccine, you're not getting anything from the virus itself. So vi- unlike the flu vaccine, where you're getting killed virus, with the COVID mRNA vaccine, you're not getting any viral particle. Okay, you're getting just the information of how to make the spike protein, and your own body produces the spike protein. So no, there's just no way you can get a COVID-19 infection from the vaccine itself. Okay, this one is from Rose. Are two vaccinations really necessary? Okay, the data shows that after the first vaccination, you get 50% immunity, and the second vaccination gives you 95% immunity. So, yes, if you want to get 95% immunity, get the second vaccination. Okay, this one is from Lee. I tested positive before and had only mild symptoms. This was 2 months ago. Should I get the vaccine and why? Okay, there are many cases like this. Now, if you tested positive before, you have some immunity, but we don't know how much and how long would it last. Now, studies have shown that the antibodies go down after a couple of months. So the recommendation is still to get vaccination, get the 2-dose vaccination, but you can wait. You will not be in the priority. Wait 3, 4, 5, or even 6 months because you already have some immunity. Okay, the sixth question. Okay, the sixth question is from Lee. Is it possible for the messenger RNA to mess up my genes and cause some unexpected and weird side effects later? Well, in our cells, the messenger RNA is synthesized inside the nucleus, and the DNA gives it the code to make whatever protein is needed. Then the messenger RNA leaves the nucleus to deliver the code to the ribosomes, which is the protein factory of the cell, and whatever protein needs to be made is made. Now, with the vaccine, the messenger RNA is created in the lab and programmed with the code for the spike protein and to deliver the code to the ribosomes. After the code is read by the ribosomes, the messenger RNA is broken down, usually after a few minutes to a few hours. So the answer is no. The messenger RNA can pass through the nucleus barrier or receive new codes from the DNA or alter the DNA. Okay, this is Charlie. Is it possible that my immune system will make other types of antibodies that might attack other parts of my body? Now, the real question here is there any protein in our body that is identical to the coronavirus spike protein? The answer is no. Okay, this is John's question. How long does the messenger RNA last after vaccination? The messenger RNA doesn't hang around very long. So after the information is read once, twice, 3 times, it is broken down. Okay, this last question is from Bert. Is the COVID-19 vaccine effective against the new variant? Now, this variant of concern, as they call it, is being watched very carefully. So right now, they say that the vaccine that we have is still effective against this new variant, but they're watching it very carefully. It is very possible that it can mutate and just get lucky that it escaped the vaccine. So hopefully that is not going to happen. So weigh your options carefully and decide what's right for you at this time. With the right economic policies, I predict that there will be a rapid recovery, and this will surprise everyone. If you find value in this video, please subscribe, give us a like, and hit the bell icon. I'll see you in the next video. My next video is preventing sudden cardiac death from a first heart attack, the role of coronary calcium scoring, and what your healthcare insurance is saying. I'll see you next time.